All right, and welcome back to the final lesson for this unit, unit number 4. We are looking at volume of composite 3D shapes. So you're looking at the volume of a variety of 3D shapes. So how do you find the volume of a composite 3D shape? Well, our goal today is to determine that, and I've got steps for you, and they're going to look familiar. So step 1 is we're going to cut the shape into basic 3D shapes. All right, so we're going to divide this composite shape up into 3D shapes that we know. Second, find the volume of each basic shape. Each basic shape. And then the third and final one is, add the volumes together to find total volume. So add the volumes together to find the total volume. So there we go. So very, very similar to area of composite shapes, except we're dealing with volume this time. All right. So let's see 3 examples on this. So here is a example of a 3D shape, and I've written over so you can see the numbers a little bit better, hopefully. So it is an L-shaped object. So we can cut this shape right here and back here, all right, to make that particular 2 rectangular prisms. Or you could be looking at it and saying, well, I prefer to cut it this way. And you can do that too. It doesn't matter. You can pick either or. So it doesn't matter to me. I'm going to cut straight down. So I'm going to have shape number 1, and I'm going to have shape number 2. They are both rectangular prisms. So volume 1 is length times width times height. So when I'm looking at the object, I need to find, what do I need to find? I need to find this length right here, and it's not given already. All right, so I know the whole bottom is 80. That's given information. So that length here is 80. I don't know that length there. All right, so how are we going to find that out? So what we need to do then is look at the other information given. I know the distance from here to here is 60. I know that's tough to read. Make it a little bit clearer for you. So that's 60, which means that if that's 60 and the yellow bar is 80, the missing length then has to be 20. So we already hit a bit of a snag there, but we worked our way through it. So that length is 20. The depth of this object is the same all the way through. So that's the 10 millimeters there. I got to write that a little bit better for you. Times 10. And the height again, 60, it was given there, times 60. So that is the area, or sorry, the volume of our first rectangular prism. So 20 times 10 times 60, probably around 12,000 cubic millimeters. All right. Volume 2, that is the other one that's on the horizontal one here. So, again, rectangular prism, length times width times height. So the length here, we talked about it, it's already 60. All right, so your length was this value here. We know it's 10 millimeters deep. And how tall is it? So what is this distance here? Well, is it not given information here somewhere? We gotta figure this out. All right, so we have another problem. I don't know that height. I know the height of the tall tower over here, the tall prism, was 60. All right, I know the height from here to here is 40. So that means that the small piece underneath the 40 will have to be 20 millimeters. So it takes a little bit, something take a little bit of work to figure out. But there we are. So multiplying them together, 60 times 10 times 20 is another 12,000 millimeters cubed, I should say. All right, so therefore, total volume is V1 plus V2. So 12,000 plus 12,000. Using your calculator, we have 24,000 cubic millimeters in that shape. Okay, so there we go. Example number 1 taken care of. Anyone with a question? Again, I can't see you guys. It's a video. Don't know whose hands are up. Come on, by now you should know that. Okay, I'm just joking a little bit. All right, so second shape. This is kind of like a hand moisturizer shape. It's a rectangle cylinder, a circular cylinder. So it would go back here. Okay, same thing with a half sphere on top, or hemisphere, hemisphere. Sorry. So that means we are going to have two shapes. We will have the cylinder, and whoa, that's kind of ugly color on top of that. And we'll have the half sphere. So let's figure out the volume of a cylinder first. Volume of a cylinder, pi times r times h. 3.14 times, what is this measurement here? The 10. The 10 extends from this side to this side. So this is in fact our diameter, which would mean our radius is half of that, so it's 5 meters. Okay? Oh, it could be a silo. All right. I'm missing the obvious here out in rural country. Now the shape is 6 meters tall, so we now have all the dimensions necessary to calculate the volume, of that shape. So 3.14 times 5 times 5 times 6. So that cylinder is 571 cubic meters. Okay, volume of shape 2. We can do this a couple of ways. It depends on what makes the most sense for you. Volume of shape 2, we only want half of it. So what we could do is we could say we want half of our volume. So the formula, and it gets a little bit ugly if we do it this way, but if there's problems, we can do it a little bit different when we talk about it in class. But the formula then would be 4 times pi times r times r times r divided by 3. And we also want to do the dividing by 2, so it actually ends up times 2 down there. Okay, so that 2 right here is where that 2 came from in the formula. So we're cutting it in half. Okay, if people are a little freaked out by that, the other way, or the alternate to this, would be to do it this way. Okay, and then we'll just say, hey, we're going to divide that all by 2. Maybe that's a little bit better right now. So let's do it that way. So 4 times 3.14 times, radius we said was 5, times 5 times 5. We're going to divide that by 3, and then we're going to divide everything by 2. All right, so 4 times 3.14 times 5 times 5 times 5 equals, take my number, I'm going to divide by 3, and then divide by 2, and we get it down to 261.7 cubic meters. So my volume total, therefore, is my first volume plus second volume. Oh, I don't know why I'm putting the units in. You don't need the units at this stage. Just need it in your final line. 261.7. So we end up with a total of 732.7 cubic meters of material, depending on what you're putting in there. All right. Then the last one. The last one, I want to take a look at the shapes here. So, do I have enough information on there? Probably not. I better add 4 centimeters there for the height in there. Okay. How many shapes do I have to cut this one into? And that's the whole catch here. It's a total of 3 shapes. I'm going to cut downward. So I'm going to cut there, and I'm going to cut there. So I'm going to have shape 1 in the middle, shape 2 on the outside, shape 3 on the outside. So volume 1. That shape that's inside, it's tough to see now, but this length here, and the ones in the homework are much, much clearer, but it's 4 centimeters. All right, so length times width times height. So that's 4 multiplied by, how tall is that section? Well, we know that, and this is going from the diagram, so I'll talk you through it. This 4 centimeters is that height there. On the outside here, I have 8 centimeters is the total height. So that means that missing distance from there to there is the difference. So it's also 4 centimeters. All right. How deep is this shape? Okay, that's given right there, times 3. So that's that middle shape. All right. 4 times 4 times 3. And I promise the homework questions, the diagrams, much more clear. I end up making a mess when I work on it at the board here. Volume 2. So looking at volume 2. What do I know? I'll exaggerate it. That hash mark and that hash mark tell me that those are the same. So I know that this rectangular prism is 3 centimeters in length. So length, width, and height. So that's 3. I know that the height from here down to here is going to be the same as this side. So it's going to be 8. And what dimension are we missing? We're missing that depth. And those guys are the same, so it's going to be 3 as well, 3 centimeters. Now what I want you to notice is, what do you notice about shape 3? I'm hoping some of you are looking at it thinking, hey, shape 3 looks an awful lot like shape 2. And it's absolutely correct. All the dimensions are the same. So I'm just going to put here, this is also equal to volume 3 to save myself some time. If it's the same shape, I'm not going to recalculate it. So volume total is equal to volume 1 plus volume 2 plus volume 3. 48 plus 72, and the last one is the exact same. So when I add that together, we end up with a total of 192 cubic centimeters. This is going to be the toughest concept because we're working with 3D shapes and you're doing it on a piece of paper, so it will be challenging. We'll bring in some maybe 3D shapes. We'll use Kleenex boxes to help kind of make it a little bit more clear as to what you're working on. But other than that, give the homework a try. See how it goes. Whatever you have trouble with, please let me know, and I will help you out as best I can. Good job on finishing Unit 4.